Hello, this brief video is about troubleshooting video laryngoscopy. It should be seen alongside a careful read of this particular paper, which is by Dr. Richard Levitan, and the exact reference to this paper will be on your screen shortly. Dr. Levitan wrote this paper and correctly established the various issues with video laryngoscopy. They are getting a view of the larynx, getting the tube to the glottis, and then advancing the tube through the glottis. This brief video is especially aimed at the situation where you've got a difficult intubation and you've just managed to get a view of the larynx with the video laryngoscope. The larynx being in a very anterior position, which it almost always is, and yet when you advance the tube up to the glottis, you cannot advance the tube past the glottis. There will no doubt be other solutions to this tricky and frustrating situation, but there are some tools which I'm going to show you which will almost always provide the solution to this particular problem. This mock-up is intended to show some of the problems with intubation with a video laryngoscope. I'm just going to point out some elements of the mock-up. This is the trachea right here with a capital T. This particular end of the plastic is to signify the vocal cords. This is a video laryngoscope obviously, and the epiglottis would be somewhere in this position. The first element of the problem when you're trying to do a video laryngoscope assisted intubation and you have an extremely anterior curve of your endotracheal tube mounted on the stylet is that it will come around the corner something like this, and it will impact the anterior tracheal wall in this position, and in this particular point here there will be so much friction with the tracheal mucosa that it's very difficult to see how this particular tube, even if the stylet was taken out, is going to advance in a posterior direction down here. In this particular mock-up, I have pulled the stylet back, and you can see that the tip is still angulated severely towards the anterior tracheal wall and is unlikely to be able to go posteriorly down through the trachea when you've got a very anterior larynx and you've got a view and you present the tube to the cords. Another factor to consider is the precise structure of the anterior tracheal wall. If you just look at this particular area here, this is the anterior tracheal wall, and it's not as smooth as in this mock-up. In fact, it's more like this drawing just here, which is intended to signify a series of tracheal rings as they intrude into the tracheal lumen. And you can imagine an endotracheal tube coming up in this position and not only touching the anterior tracheal mucosa, but touching a tracheal ring and being inhibited by that ring and unable to actually make progress down in this direction here, down the trachea. The next issue to consider when looking at an endotracheal tube is how rigid it is. This particular tip, if I try and deviate it, thinking that it might have to deviate in this direction to go down into the trachea, it's actually quite a rigid structure. You'll also notice that the general structure of the tube is a relatively rigid preformed curve, which also inhibits it performing this kind of deviation. The next element of the problem is that just looking at this tube, if I wanted to spin the tube, that is to rotate the tube on the malleable stylet which it's attached to, it can actually happen, but it's quite rigid. It doesn't really want to spin on this stylet. It's quite resistant to doing that, even with some lubrication. The next item I wish to show is what happens with a gum elastic bougie when you are able to get it to come around and impact the anterior tracheal wall. The tip of this bougie will in fact not go posteriorly down the trachea. If you try to spin the bougie to go in this sort of direction, it can flick out, as I've just done there, rather than to actually go down to the tracheal lumen. So the bougie, which normally is a great friend to us with difficult intubations, impacts the anterior tracheal wall and has the same problems as the tube. It has too much friction, and when you spin it, in this case, it dislodges. I now wish to go over some of the elements of the equipment that you will need to solve this particular problem. And the first thing is to have a look at the kind of tube you would use for a very difficult intubation with an anterior view of the larynx with a video laryngoscope. This particular tube is a pretty standard reinforced tube, and you'll notice that the tip is very, very floppy compared to a standard endotracheal tube. The next thing is that the shaft is very floppy. The next part of the solution I wish to show you is the ability of this particular tube to spin easily on the malleable stylet. You're going to need a lubricant applied in a couple of different places. Another potentially very helpful piece of equipment in this situation is a standard fibre optic laryngoscope placed in the right position up into the anterior tracheal wall, which I'm doing now, and then directed posteriorly. You can imagine that as this fibre optic goes down into the correct position as I'm advancing it now, you can then advance an endotracheal tube up to the larynx and down the trachea. The next part of the solution involves a brief understanding of friction. I've put some lubricant on the tip of the endotracheal tube so that when it abuts up here against the anterior tracheal wall, in fact, it's going to be easy to break the friction on the anterior tracheal wall because of the lubricant. I've also put lubricant on the inside of the tube around the malleable stylet so that it's very easy to twist and rotate this particular tube on the stylet. Now the reason for this is that should you get a tube in this position here and you're really trying to have it advance down the trachea, it's very helpful if the tube itself starts to spin, and it will break the friction at the tip, whether it's up against the mucosal wall or whether it's up against the tracheal ring. And once it's rotating, as you can see it doing now, then it will start to advance itself down through the trachea because the spinning has allowed it to break that friction. The next image we are going to show is of an intubation with the mock-up that you've seen, and then we will show video of actual live intubations. I have mounted a 7.0 reinforced tube with a lubricated flexible tip on a stylet with further lubrication between the tube and the stylet itself. It comes around, it hits the anterior tracheal wall, and it does not want to move. I pull the stylet back, and I've pulled it back a couple of centimeters here, and then we're actually going to spin the endotracheal tube on the stylet, and you'll start to see it spin, and you can see how it's broken the friction on the anterior tracheal wall, and it's going to advance down off the end of the stylet and down into the trachea. So the elements of this again, if we just come back, are a very flexible tip, pulling back the stylet to free up the tip. Once it's in the anterior tracheal wall, it may just go down, but if you spin this tube on the stylet, what will happen is that it will start to go down the trachea. And I'm just going to spin it now, and it will start to go down the trachea, just as I'm showing now. The next image shows the use of a fibre optic scope in combination with a video laryngoscope. The fibre optic scope is advanced to the cords in a fairly standard fashion, and then the tip is directed posteriorly down the trachea. Next, a suitable flexible tube is advanced over this fibre optic scope down the trachea, and this is usually made much easier with a twisting motion, as you will see in the following video. The following images are of actual video laryngoscope intubations. They all show the use of a smaller sized endotracheal tube, usually a 7.0 size, which makes all intubations easier than with a larger tube. The tube itself is flexible at the tip, which, as we've seen, helps to break friction with the tracheal wall, and it's also flexible in the shaft, which will help any twisting motion that is needed. The procedure itself involves exposing the cords with the video laryngoscope, then presenting the tube to an area just above the cords. This is followed by pulling the stylet back 1 to 2 centimeters to free up the flexibility of the tip, and after this the tube is advanced over the stylet down the trachea, and usually a twisting of this tube on the stylet will assist the process.